we will solve the following exercise. The exercise is the number 2.43. The tensions in the four cables are equal. T1 equals T2, T3, T4. And I'm going to call it just T. Determine the value of T so that the four cables exert a total force of 12,500 pounds. Magnitude of on the support. Alrighty. So basically, for we to solve this exercise, we have to take into consideration just one concept, and it is basically that for when you want to determine the magnitude of a vector, you have to take into consideration two things. The first one is the magnitude along the x-axis, and the second one is the magnitude along the y-axis, because basically, for example, taking into consideration this vector, you will have two components, all right? And the two components are going to be given by the total vector, all right? You just have to draw some parallel lines and you will find the two components. Now, taking that into consideration, we will determine first the component along the x-axis and then the component along the y-axis. How's that? Well, every single one of them are going to be equal to T. So for the x-axis, I'm going to find T multiplied by the cosine of 9 plus T multiplied by the cosine of 29 plus T multiplied by the cosine of 40 plus T multiplied by the cosine of 51, right? Now, I can do a distribution taking out that T from the summatory between the cosines, and I'm going to be able to find this T multiplied by, open parentheses, cosine of 9, cosine plus cosine of 29, plus cosine of 40, plus cosine of 51. All right, and the answer is going to be T along the x-axis, which is the one I need, the first one I need. Alrighty, so on the calculator we will solve the summatory between the cosines. So cosine of 9 plus cosine of 29 plus cosine of 40 plus cosine of 51. You have to make sure that the calculator is using degrees, and that's it. So this is equal to T times 3.2576. There is some general question that I found along the within the comments, that is with respect with the decimal places that I'm using. So as I just did, I'm going to use 4 significant digits after the comma. Why is that? Because I'm used to it. You can use 2, you can use 3, you can use 4, 5. Of course, this is a complete new subject that I'm going to explain at the end of the video if you want to stay, but basically it is because I'm used to it, and of course the more significant digits to use, you will find an accurate solution. for the exercise. Now, I'm going to explain that at the end of the video, but for now we just have to be focused for this exercise. On this exercise, sorry. Now, this is going to be equal to tx, which is the component along the x-axis for t. We're going to do the same thing for the y-axis. So for the y-axis, we will find basically the same stuff, but using sine instead of cosine. So t sine of 9 plus sine 29 plus sine of 40 plus sine of 51. This is equal to ty. Now sine 9 plus sine 29 plus sine of 40 plus sine of 51. Let me check that I wrote everything correctly. Yep. 2.0611. So t times 2.0611 equals ty. Right? So we have the components in terms of t, because we don't have the solution for t, and we just have to find an equation that relates the magnitude of the components together and the magnitude of t, and that is basically the equation of Pythagoras, I think that is called in English. So we will find, okay, I don't like that color. So tx plus ty, every single one of them is squared, and I'm going to use the square root, is going to be equal to t total. And t total, which is the magnitude of t, is equal to 12,500 pounds. All right, because that is one of the requirements that we have to meet. Now, I'm going to write down the equations, which means that t times 3.2576 square plus t, plus t times 2.0611 square, and the square root of all that have to be equal to 12,500 pounds, right? So we have one equation, one unknown. Basically, the exercise is solved. Of course, I would have to use this squared and start playing with the solution, and I don't want to do that because I think it's not necessary since we have the calculator. So basically all we have to do is to write down the equation, and the calculator is going to give a solution for t, which in the calculator I'm going to call x, right? So the square root of, in parentheses, x times 3.2576 close parentheses square plus x times t2, I'm sorry, 2.0611 square is equal to 12,500. Now I'm going to press Shift, solve, for me to solve. Yes, I want to solve the equation for x. And finally, the answer is t equals 3,242.6440 pounds. All right, let me check. Yep, all right, that is the answer, guys. This is all for this video, for this exercise, because of course I'm going to explain what I promised before, which is the use of decimal places. What happens? Of course, the more decimal places, the more decimal numbers you use, the more you'll find an accurate solution. For example, in the case of pi, which is 3.141592, whatever. If I use, for example, just the 3.14, I'm going to create an error. Okay, that error is going to be available during all the number, because as you may know, pi is an infinite number, so these numbers do not stop ever. So that depends on what I want for the solution. If I'm going to be able to accept that error depends on what I'm doing. For example, if I'm going to build a building, and I'm not going to be able, or my math is not going to be able to accept an amount of error, of course I'm going to have to use more digits and more digits until that error is acceptable for what I want to do. I'm going to create a chart. Right here we have the percentage of error, and right here we have the number of decimal numbers. Now, for example, and this is just an example, this is what some engineers and some mathematicians do for a living. I'm going to use 2, 3, I don't know, 100, 2, 300, whatever. Of course, the percentage of error is going to decrease along the number of decimal places of decimal numbers increases, like this. But, and this is a little advanced, during this analysis you will find an amount of decimal numbers that is going to increase the error instead of decreasing. And this looks like this, something like this. In this case, it could be, I don't know, 76, whatever. I don't really care about the numbers, but there is going to be a moment in which if you use more significant digits after the comma, you will increase the total error instead of decrease it, which is not what we want. So the mathematicians, the engineers, have to be able to locate the minimum I don't even know how to write minimum percentage of error acceptable. All right, it could be this one, it could be this one, it could be, I don't know. So they are going to be able to find the number of decimal numbers that they could use. And this is all. So why do I use 4 significant digits? Because I'm used to it. That is the answer. Of course, if you are going to use more significant digits, you will find an accurate, a better solution, but you have to make sure that that amount of decimal placers are decreasing the error instead of increasing the error. And that's pretty much it, guys. I hope this is this was a pretty good explanation for the decimal place, for the decimal numbers, and for the exercise. And that's it, guys. This is how you can solve this exercise.